What is Internet of Things? The Internet of Things describes physical objects that are embedded with sensors, processing ability, software, and other technologies that connect and exchange data with other devices and systems over the Internet or other communication networks. Now that we already know what IoT is, let's discuss first the history of it. In 1970, the actual idea of connected devices was proposed. In 1990, John Ramke created a toaster which could be turned on and off over the internet. In 1995, Siemens introduced the first cellular module built for machine-to-machine. In 1999, the term Internet of Things was used by Kevin Ashton during his works at P&G. In the year 2004, the term was mentioned in famous publications like The Guardian, Boston Globe, and Scientific American. In the year 2005, UN International Telecommunication Union published its reports on this topic. And in the year 2008, the Internet of Things was born. In 2011, Gartner, the market research company, include Internet of Things technology in their research. How IoT works? Internet of Things works using these components: sensors or devices, connectivity, data processing, and user interface. First is sensors or devices, a key component that helps you to collect live data from the surrounding environment. All this data may have various levels of complexities. And the second is connectivity. All the collective data is sent to a cloud infrastructure. The sensor should be connected to the cloud using various mediums of communications. And the third is data processing. Once that data is collected and gets into the cloud, the software performs processing on the gathered data. This process can be just checking the temperature, reading on devices like AC and heaters. Fourth is user interface. The information needs to be available to the end user in some way, which can be achieved by triggering alarms on your phones or sending them notifications or text messages. This user sometimes might need an interface which actively checks the IoT system. Next, let's move on to the applications of IoT. IoT is being used at home as the consumer. It can also be applied in transport or mobility. in health or medical field, in development of infrastructures, and lastly, in industries. It can also be applied in smart thermostats, connected cars, activity trackers, smart outlets, parking sensors, connect health, smart city, smartphone, and smart supply chain. Smart thermostats help you to save resource on heating bills by knowing your usage patterns. Connected cars. IoT helps automobile companies handle billing, parking, insurance, and other related stops automatically. Activity trackers, wherein it helps you to capture heart rate patterns, calorie expenditures, activity level, and skin temperature on your wrist. Smart outlets. Remotely turn any devices on or off. It also allows you to track a device energy level and get custom notifications directly into your smartphones. Parking sensors. IoT technology helps users to identify the real-time availability of parking lot or spaces on their phones. Connect Health. In smart cities, it offers all types of use cases which include traffic management to water distribution and waste management. Smart homes. Smart homes encapsulates the connectivity inside your homes and includes smoke detectors, home appliances, light bulbs, windows, doors, and etc. And lastly, the smart supply chain. Here are the key benefits of IoT technology. Technical optimization. Improve data collection. Reduce waste. Improve customer management. Here are the disadvantages of IoT: security, privacy, flexibility, complexity, and compliance. Security. IoT technology creates an ecosystem of connected devices. However, during this process, the system may offer little authentication control despite of sufficient security measures. Privacy. The use of IoT exposes a substantial amount of personal data in extreme detail. Without the user's active participation, creates a lot of privacy issues. Flexibility. There is a huge concern regarding the flexibility of an IoT system. It is mainly regarding integrating with another system, as there are many diverse systems involved in the process. Complexity. The design of the IoT system is also quite complicated. Moreover, its deployment, maintenance also not easy. Lastly is compliance. It has own set of rules and regulations. However, because of its complexity, the task of compliance is quite challenging. And now let's proceed to the best practices of IoT. Design products for reliability and security. Use strong authentication and security protocols. Disable non-essential services. Ensure internet managed and efficient algorithms. Internet connectivity. All IoT devices require a mechanism to receive and send data. The next topic is cryptography. Let's discuss first the information technology security before we proceed to the cryptography. So, what is information technology security? IT security is the protection of information and especially the processing of information. IT security is intended to prevent the manipulation of data and systems by unauthorized third parties. Physical security, cybersecurity, and information security. Security threat. It is a malicious act that aims to corrupt or steal data or disrupt an organization's systems or the entire organization. Passive threats. Release of message contents and traffic analysis. Active threats include replay, masquerade, denial of service, and modifications of contents. Here are the security goals: confidentiality, integrity, and non-repudiation. Confidentiality, the state of keeping data and information in private. Integrity, the state of being whole and undivided. And lastly, non-repudiation, assurance that the sender of the information is provided with proof of delivery and recipient is provided with the sender's identity. Now that we are done with the information technology security, let's discuss the cryptography. Cryptography refers to secure information and communication techniques derived from mathematical concepts and a set of rule-based. What are the advantages of encryption? Encrypt data can't be easily read. Strong encryption may require years to work to decrypt without the key. And disadvantages of encryption. Encrypted files draw attention to their value. For large files, strong encryption may take significant time to decrypt. If you lose the key, you lose the data. Symmetric and asymmetric cryptography. Symmetric encryption is an older method of encryption. It is faster and more efficient than asymmetric encryption, which take a toll on networks due to performance issues with data size and heavy CPU use. Asymmetric encryption, known as public key cryptography. It is a process that uses a pair of related keys, one public key and one private key. This is asymmetric. Here is the conclusion about cryptography. By using of encryption techniques, a fair unit of confidentiality, authentication, integrity, access control, and availability of data is maintained.